Hey everybody, this is your 7.1 Math Excel video. This lesson is called Attributes of Exponential Functions. So basically x is the exponent. So previously we did square root functions, which are called radical functions, which look like that. Basically it rises slow. In these, exponential functions rise fast, unlike square root. There's also a couple of properties or, attributes, characteristics, all that. And one of them is unless there's a leading coefficient, they go through 0, 1. Now what I mean by leading coefficient is no number in front of the term here. Like this one just has 6 to the x, and so it's 1, and so that's what I'm talking about. That would go through 0, 1. Even if it were like 100 to the x, that would still go through 0, 1. Okay. The y values are never negative unless you had a negative coefficient for some reason. But I didn't see any of those in this problem set. So my graph looks like that. Your very first one is just about choosing a multiple choice graph. Also, I'm just telling you characteristics like if it's 6 to the x, that base is 6. And so think of 6 to the 0 as 1, which is why it's the 0, 1 ordered pair. And then the next one would be 1, 6, then 2, 36, and so forth. So it grows very fast. Okay, on the next one, it says determine if it's exponential growth, which is when your base is bigger than 1, or if it's decay, like between 0 and 1. So usually, if you have word problems about decay, are usually half-life. Because your base would be a half, because a half is between 0 and 1. So you cannot have a negative base. They have to be between 0 and 1 or just bigger than 1. Now in this one we were given 5 times 4 to the x. So your a is the 5, your b is the 4, which is your growth rate, and your y-intercept would be 0, a. It is exponential growth because it's all positive and it's bigger than 1. This particular one wants your y-intercept in the form where it's just a number, not an ordered pair. So if you have 0, 5, then just put 5. It says type an integer or a decimal. Now there are a couple of others later in the lesson where it does want the ordered pair for the y-intercept. So just read your directions. The next one says determine if it's exponential growth or decay, and then your y-intercept. So we have 0.5 times 1/9 to the x. Because this is bigger than 0, but less than 1, it's decay. And your y-intercept would be the ordered pair 0, a half, or 0, 0.5. On your next one, it's a word problem. This is where exponential functions apply to everyday life with money. So on this one it says suppose you deposit $3,000 in savings that pays an annual interest rate of 7%. So you're going to probably have a different deposit amount and rate. It asks if no money is added or withdrawn, how much is there in 5,000 years? So to do this equation, it's a of t, and think of your initial amount, your initial deposit goes in front. So that would go through the ordered pair 0, 3,000. If you're trying to graph these, you're going to have to adjust your y-intercept, but I didn't have to graph any. That would be your initial deposit, and you're earning money, and so that means you have to add 1 to the percent. If it's 7%, then you put 0.07. So you're always going to have 0.0 something unless your rate is 10% or greater. So it's always going to end up like 1.07, 1.08, 1.04, unless you have 11%, which is like 1.11. And then you need to know your exponent, which in exponential functions is your variable. Well, in this case, it's going to be the number of years. And since it says 5 years, then we put a 5 there. So you basically round to the cent, which is the hundredth. You do your 3,000 times 1.07 to the fifth. So make sure you do your 1.07 to the fifth first, then times 3,000. If you're using our calculators, then it does the order of operations for you. And then it asks you to do for 15 years, so you put a 15 there. Then it wants you to say how many years to achieve 3,500. Well, one way is to use the graph, but then you'd have to say your graph would have to have a y max of, say, 4,000 or 5,000. What I'd rather do is just look in the y column of your table, and if you're looking for above 3,500, then it's between 2 and 3, because we have 34, 3470, and 3675, 13. So right there you can stop, since it's 3,500 is what we were looking for, and you have to round up. So if you want at least $3,500, then that'd be at least 3 years. And then it's asking about 4,000, so you just look further down in your table. At 5 it were 4207.66, and so that would be our answer, because at 4 it was still 3932. So you stop once you get to your number. On the next one, lower than expected demand for LCD TVs has spurred manufacturers to cut prices in recent years. The average price P of a 32-inch TV T years after 2006 can be approximated using the formula 1200 times 0.772 to the T, where T corresponds to 2006. Then they want to know the average price in 2008. So all you do is you take this year minus that year to give you 2, which is your exponent. And then you just do P of 2, which means take your number, 1200 times 0.772 to the second power, and then that's your answer. And I think these wanted whole number answers. This was 715, and then for 2012 we use 6, because 12 minus 6 is 6, and then plug it in and we get $254. So that's quite a difference in price, with it dropping, obviously, but that's how you do it. The next one says, write an exponential function to model the situation. It says a population of 130,000 grows 5% per year for 16 years. That tells you a lot of information in that sentence. If it tells you the population, that's the y-intercept, which goes in front. That's your coefficient. And if it says grows, then it's going to be 1 point something. In this case, growing 5% would be 1.05 for your base. Now, if for some reason, like on another lesson or whatever, it says loses 5%, you would have to say 1 minus 0.05 and get 0.95. So that's how you would approach that. And then it tells you your number of years. Well, for the first part, they already have the x as the variable. And then for part 2, you just plug 16 in, sub 16 in for x, and they want you to round to the whole number. So you can do that pretty easily through the calculator. The next one is extra practice A. This is the last one. Given the annual rate of change, find the corresponding growth or decay factor. So your formula is a b to the x with b greater than 1, and your exponential growth would be b, which is equal to 1 plus r. So the easy way to think of it is if it's 900,000, drop your zeros, and your growth rate would be 9. And so then you do 1 plus 9 to get 10. So 10 corresponds to 900,000. I'm sorry, just 900%. So you get your growth rate and add 1. Now you may see one that's not in the hundreds. Like this example is if it's 10%, then the first step would be 10% is really corresponding to 0.1, and then you say 1.10. So that's basically how you do it. Okay, hope that helps.